Hi, you see our topic here for today is to find the volumes of both prisms and cylinders. And later on you'll see how the formula for both prisms and cylinders is very similar, and so it makes sense just to group those two together. We first need to define volume. It's the space a figure occupies, and the units will be always in units cubed. And so those specific units may be centimeters cubed, feet cubed, meters cubed. You just need to pay attention to the problem and what type of given information you have. So volume, in essence here, if we focus on this 1 by 1 by 1 centimeter cube, the volume of each of these rectangular prisms is how many of these cubes fit within each rectangular prism. And so whatever your answer is to that question, that'll be your volume. And again, the given units here is centimeters, so your volume units will be centimeters cubed, or it can be read as cubic centimeters. Cavalieri's principle states that if two space figures have the same height and the same cross-sectional area at every level, then they have the same volume. So here we're given three different prisms. Two of them are rectangular prisms and one of them is a triangular prism. This first one is a right rectangular prism because it's going up at right angles, whereas the middle one is an oblique rectangular prism because it is going up. You see there how it's sort of slanted to the side. And then this third one is a triangular prism, which is also right because it appears as if its lateral sides are perpendicular to the base. So if we look at the cross-sectional area, this first one is a rectangle. It's a 3 by 2 rectangle. And so the cross-sectional area of the first one is length times width. In this case, it's 3 by 2, and it gives us 6 centimeters squared. The middle one there has the same cross-sectional area. It'll come from length times width still, which is 3 times 2, and so it is 6 centimeters squared. And then this last one, the triangular prism, its cross-section comes from the area of a triangle. And so it's 1/2 times 6 times 2, and you'll notice that that's going to result in 6 centimeters squared. Therefore, using Cavalieri's principle, because all of these prisms have the same height also, that we can state that their volumes are all the same. Here's our formula to find the volume of a prism. This formula will work whether that prism is a right prism or an oblique prism. We'll still use this same formula. Pay close attention to capital B there, representing the area of the base. And so don't think that that B stands for just the length of a base. It is the area of the base. So this formula will work regardless of the type of prism. As long as we can find the area of the base, then we're going to take that and multiply it by the height of the prism, and that'll give us our final answer. And so we can use that here with this figure on the left, this rectangular prism. If we look at that bottom side as the base, to find the area of the base, since it appears to be a rectangle, we would do length times width, which would be 20 times 24. This results in an answer of 480 centimeters squared. And now we can use our volume formula. Volume equals area of the base times height, and so we'll take that 480, we'll multiply it by the height, which is 10, and therefore our final answer is 4,800. And then pay attention to units. These are centimeters cubed. Now we're going to find the volume of a triangular prism. And you'll notice here how this prism is oriented a little bit differently. We are still going to use that same formula. Volume equals area of the base times height. Now I know the height is 10 inches because if I stood that prism up, I typically think of prisms as standing on their bases, and so if we oriented it vertically, you would see how that 10 inches would become the height. So we need to find the area of the base. In this case, it's a triangle. So the area of the base is going to be 1/2 lowercase b times h. And so you'll see there that we have an equilateral triangle. Let me just sketch out on the side here that equilateral triangle. We're going to need to remember special right triangles here. That's going to be 4. This angle right here is a 60-degree angle, so therefore the height of my triangle is going to be 4 radical 3. Now once I substitute this in, it's going to be 1/2 times the base is 8. The height is 4 radical 3. So this will result in an answer of 16 radical 3. So that's big B. Now I'm ready to go over here to my volume formula and substitute that 16 radical 3 in for the area of the base. And then I'm just going to multiply it by the height. And so you'll see that my answer is 160 times radical 3. The units for that, since I'm dealing in inches, will be inches cubed. And now, as with any multiple choice question, we always have to cross-reference that with our answers. And so I'll go to the calculator now. I'll type in 160 times radical 3. And I end up with roughly 277. So my answer for this problem would be letter B.